Alright, so we're going to be going through GBA at C. The main thing to notice is video buffer. And this video buffer starts at this address, and it's a massive array of 38,400 pixel values. And so if you want to change this on the screen, you just have to change the indices, basically the values in this array. In the next frame, it's going to redraw those new values onto the screen. And so you have to know it's a 1D array. So although conceptually it feels like it should be a 2D array, it's actually implemented as a 1D array. And so we have to do some math to basically convert our 2D notion of like the physical pixel space to the actual 1D index in the video buffer. And that's already given to you over here with this offset macro. And so if I want to set a pixel to a color, I can just do this and just access the video buffer. I need to give a 1D index, but I can use my offset to do that for me. I'm going to give a 2D position. And the offset will naturally convert that to the actual appropriate index of the video buffer, and I can just set it to color. Just like that, your set pixel should be working. There's also this wait for v-blank function that we should do. And so if you imagine if you're drawing on the screen, it takes a finite amount of time, right? It takes some actual time for the whole screen to be drawn, and we don't want to update the screen in the middle of while it's drawing the pixels, because then you're going to have half of one image and half of another image, kind of like that, and it's going to call it screen tearing. And so to do that, there's this little dead zone called v-blank, and we just want to make sure that our scanline counter is going to be there before we draw things, and that's what this wait for v-blank function is going to help with. And to just ensure the scanline counter is over there, all I have to do is first, got to make sure we're not like down there or something. That's this first part of the loop is going to be while scanline counter is greater than 160. So while we're below this target destination, we just got to keep looping. And we also got to make sure that the scanline counter is not like actually drawing the screen right now. And that's going to be the second part. Line counter is less than 160. And after these two parts, we're basically guaranteed that our scanline counter is going to be exactly where we want it, which is right there at the beginning of v-blank. And we're also going to keep a personal counter called v-blank counter. And I believe the really nice thing about this counter is that it allows us to have a timer. So this is not like required, but this is really good to do because we know there's 60 frames a second. We know if there's 60 v-blanks have passed, 1 second has passed. So we can basically hack up a timer in the game now. Anyway, that's for later. And now we're going to talk about DMA. Alright, so in order to use DMA, there's a couple things you have to set. We're going to set DMA3.source, and this is going to take in a pointer to the color. And you can kind of conceptualize DMA as basically copy and pasting chunks of pixels. And so this dot source is basically, we have a color here. It's going to take in a pointer to that pixel. And this basically copies the color of the pixel. Again, think of it like that. And DMA3.dest is our next thing we're going to set. This basically takes the location on the video buffer. Imagine the screen is here. Might have the video buffer location right here. I'm going to take in a pointer to that spot. And this basically is where we paste this source color to. That's what specifies. So, and then we have our DMA3.control, and we'll get to that later. But first of all, let's set our source. So what do we want to copy? We want to copy the color. We have to give an address of the color, so that way it turns into a pointer basically. So what we're going to do is ampersand of color, DMA3.destination. In order to fill the whole screen, we probably want to start with the first pixel on the screen, which is the top left. So I'll pass in a pointer to that top left part of the screen. So it's going to be the 0th index, the very first pixel, video buffer 0. I'm going to use ampersand to get the address of that. And now we have this DMA3.control. And there's a lot of things that you can basically pass into this DMA3.control. It's a bit mask, and there's a lot of things you can OR together to compose some functionality from DMA3. But for this homework, I'm going to simplify that because really, you don't really need these other ones. I really doubt that it's going to be useful. The only things that might be useful is going to be these values. So these are only 4 values they have to worry about. And I'll get through what all the means in a second. So the first thing is DMA source increment. So the first thing we have to do is decide how many pixels do we want to paste, right? And so in this case, we want to paste 38,400 pixels. We want to paste basically this color into all 38,400 pixels. So the first thing you're going to do in U.CNT is set it to the number of pixels we want to draw. If I wanted to paste 50 pixels, I type 50. In this case, I want to type basically the whole screen worth pixels, so width times height. And the next thing you're going to do is you're going to turn DMA on. And this ridiculous sounds is just, you basically just want to turn this on every time you're using DMA. Because if you don't, it's not going to be on, and you basically wasted your time. Like, what's the point of full screen DMA if you're not going to turn it on? So just make sure this is on all the time. And it's really that simple. This will be on in all of your DMA calls. Now, next thing is we have to decide. It's pretty much always going to be destination increment, right? And what destination increment means is that you can think of DMA as like a glorified for loop that runs for width times height iterations, or whatever you decide to put here. And if you turn DMA destination increment on, so let's do that right now. Every loop iteration, like the first loop iteration, you can imagine as it's going to copy this pixel and paste it there. And then the next iteration, it's going to, because you turn DMA destination increment on, it's going to shift this pointer over by 1. It's basically going to add 1 to it. And now it'll be pointing to next pixel in line. And so in the second loop iteration of this width times height number of iterations, it's going to paste there. The next iteration is going to move this over. Paste 1. And great, it's going to do that 38,400 times until it gets the last pixel. So that's what DMA destination increment is. And you really pretty much choose it all the time. Like, I don't really think there's a method that doesn't have DMA destination increment. So DMA on, DMA destination increment, you basically have it on all the time. Now, really the only choice you really have to make with DMA is DMA source increment or DMA fix. Now, DMA source increment does a similar thing with DMA destination increment. If we had a bunch of pixels here, like a series of pixels, what DMA source increment would do is basically the first loop iteration, our source pointer is going to be there. The next loop iteration is going to be there. And it's going to paste a different pixel color now to this whatever spot your destination is pointing to, and on and on and on. And so that the reason why that might be useful is that in this case we're only pasting a single color, but maybe we want to paste the whole background image where like every pixel is different. You can imagine you have this draw full screen image DMA. It's going to be a huge series of pixels. And we want this source pointer to increment along with the destination pointer in harmony. If you know what I'm saying. So it would look like this. Kind of see what I'm saying, right? It's going to, they kind of increment together. That's what this DMA source increment might be useful for. But for our case, where we're just doing one fixed color, we want to keep it as DMA source fixed. And that's really it. So there's a caveat to DMA. And it kind of has to do with the source increment, destination increment. Is that if I wanted to draw a rectangle here, This rectangle has a jump in memory address, right? So if we have 1 pixel here, the next pixel, basically, that's +1 from an address, gonna be right there. We don't want to draw that pixel. We want to draw the pixel on plenty of memory address later, right there. That's our next pixel we want to draw. But DMA can't really handle these sorts of jumps in memory. And so we can't draw this whole rectangle in one DMA call like we could with the whole screen. So all we have to do to solve this problem is we'll just draw as much as we can at a time. In this case, we can really only draw 1 row at a time before we get our jump in memory to this next row. So we'll just work with that, and we'll just make a for loop and just call DMA once per row to draw the rectangle. So we're going to do that. Start with the first row. DMA 3.source. What is our source pixel? Well, we want it to be a fixed pixel that's pointing this color. We'll just set DMA source for the color. And DMA 3.dest. So what's the first pixel we want to draw? The first pixel we want to draw is that pixel. That pixel is going to represent a video buffer. Offset row call. And remember, we also have to pass in this width parameter for offset. Feels kind of redundant, to be honest, but that's just the way the macro is designed. And make sure that's an address, because we want a pointer to that location. Now DMA 3.control. Well, remember, first thing is, how many pixels do we want to draw? In this case, we can really only draw a width number of pixels at a time before we have to restart and do a separate DMA call. We'll just do width. Remember to do DMA on. That's the first 2 steps. And we always want to have DMA destination increment on. Basically, these 2 are pretty much always on for all the time. And then now I have a choice: DMA source increment and DMA source fixed. We already realized that we only have a fixed color to work with. We don't have any pixels to the side of our source, like as if it was an image. That would be undefined behavior if we started like incrementing pointers and past this color pointer. So we want to keep this as DMA source fixed. And that would draw us 1 row. And so to draw all the rows, we'll just wrap in a for loop. Row equals 0. Row is less than height. I want to loop height amount of times because we want to do 1 call for every thing. R plus plus. Let's paste this all in there. And the only difference is we just need to offset subsequent DMA calls by this little R variable. So next time we want to draw 1 row down. And think this offset's going to do our calculation for us. So, row plus R. Because the next DMA call, our first pixel we want to draw is going to be this pixel, right? So we want our DMA pointer to be pointing there. The next loop iteration, the first pixel of our DMA call is going to be there. So we want our DMA dest to point there. Does that make? Hopefully that makes sense. And yeah, that's really it, I think, for draw rect DMA. And for the image version, where you basically have, instead of 1 color draw, you want to draw like a whole image. Similar process, except you probably want to change DMA source fixed to DMA source increment, so the pixels increment together. Make sure that your source is the same size as your width or height, though. Yeah. Also, this key just press macro is something you all have to do. And it's actually just simple as you just basically want to check if the key is down in the current frame. That's great. But it's only just pressed if it wasn't down in the last frame. So basically, I think you just do key down key buttons. And then you can also do and not key down. Key hold buttons. And just to be safe, remember our macro rules. I'm going to wrap everything in parentheses. Because, you know, copy and pasting can be dangerous. And that should be it, I think. This actually isn't the way I was taught to do it, but I feel like it'll work. So, if it doesn't work, then you might want to do like something similar to this.